Okay, morning everybody. Okay, this section here we will talk about the idea behind making a magnet, or how to make a magnet, and actually how to destroy a magnet, or to be exact, to destroy its magnetism. Okay, we will highlight a few ways of making magnet. How do we imbue the magnetism into the material, and how do we actually remove that magnetism effect? Okay, that's under magnetism and demagnetizations. Okay, now here we go. Let me adjust this screen first. Now, the idea of imbuing the magnetism, of giving or making a magnet, okay, or letting the material possess magnetic effect. The idea behind it is to actually align what we call the magnetic domains. Okay, but to understand that, we need to understand the theory behind magnetism. Okay, I would say the basic one that we see in your primary school, you will know that magnet, okay, they always come in pair. So let's say if I have a north and south, okay, you'll find that if I actually cut it into several parts, you'll find that these individual small parts, I will still have the North Pole and South Pole appearing on its own. Okay, so it doesn't mean that if a magnet only have one pair of pole, it will always have only a pair of pole. Okay, it doesn't mean that if I cut at these two corners, okay, they only have a North Pole on this corner, South Pole on this corner, and the middle I'll get nothing. No, it doesn't work that way. You'll find that if I cut, you'll find that the individual small item will still become an individual small magnet itself. Okay, why is it that? Okay, why is it because of that? It's because the idea of magnetism actually arises from the magnetic domains. Okay, the interior, the atomic structure of the material itself. It's not something that is, I would say, it's not something that you can stick on, like a piece of sticker you stick on, there's a North Pole, you remove the sticker, the magnetism disappears. No, it's something about the magnetic structure. Okay, and what the structure we are talking about is the magnetic domains. Okay, what we are looking at is, go back to chemistry, the magnetic structure. Okay, whereby we are actually looking at the magnetic structure, but now we look at it in terms of the magnetism, or what we call the atomic magnets. What we do here is we actually want to do one thing. Okay, we actually want to align all these magnetic domains, because by nature, all the material that arrive naturally, the metal, steel bar, iron bar, okay, they are all actually magnets. It doesn't possess magnetic properties. It doesn't possess any magnetism. The idea is because the domain inside the metal itself they are actually pointing at random locations. Even let's say that we have these particular domains here. Let's say I have a north here, you have a North Pole on one end, South Pole on the other end. But because all the domains are misaligned, pointing in every direction, any directions, they literally actually cancel out or whatever small magnetism effect they have. And because of these cancellations, you'll find that the material does not possess any magnetism effect. So what you're trying to do now is this. Okay, when a piece of magnet, okay, is brought close to this magnetic bar, okay, or this magnetic material. Remember, it has to be magnetic material. So this bar here is not a magnet, but it has to be a magnetic material first, which means it's a material that is capable of being attracted to magnet, or is capable of becoming a magnet. Okay, not just any random metal bar like copper. Okay, it has to be magnetic material, iron, copper, cobalt, all this. So what happens when this material and a magnet is brought close to it? You'll find that the magnetic domain now actually will be aligned. Every one of them will be actually aligned. Because of the magnet itself, I will actually align the magnet bar, okay, to the structure itself. Okay, the magnet will actually align the domains all into a single structure. And because of that, okay, you'll find that because of these alignments, I will actually be able to create, or to be able to allow the metal bar to possess magnetic effect. And this is what we then this is how we, and because they are all aligned in a single direction, you'll find that all the arrows actually point in one direction, point to the right. You'll find that because the arrow point to the right side here will become your North Pole, and the south end here will become the South Pole. And why is it this way? Why not North Pole on the other end? Why not South Pole on the other end? It literally still go back to the same basic, whereby I will want to attract, unlike pole attracts. And what causes the attraction? You'll find that it has to be an unlike pole that causes the attractions. Okay, so the pole that are induced here has to be opposite pole to your North Pole. Okay, so that's why this end here has to be a South Pole, because unlike poles attracts. Okay, because unlike pole attracts, and because this end is a South Pole, automatically the opposite end will be a North Pole here. So in general, when you talk about imbuing a magnetism effect onto a piece of metal, a piece of magnetic material. What you are trying to do is that you are actually trying to align the domains in a certain directions, and because of the alignment of the domains, the bar itself actually now possess the magnetism effect. Okay, the magnetic material, magnetic property. Okay, now, okay, so things to take note here is just take note at the corner here. You'll find at the corner here, okay, the two corners here. Okay, the arrows are actually slightly diverted out. They are pointed away from each other. They're what we call a fan out formation. It's slightly fan out because why? Because now you have all the north pole here. Okay, all the north pole, all the south pole here, and this is what we call light pole. Okay, and because light poles means light poles, they are the light pole repels, and because of the repulsion, all the north pole, all the arrowhead, they will actually fan out a bit. Okay, they will fan out a bit. Okay, they will repel each other a bit. Okay, this because of the repulsion, it causes this fanning out effect. Now, in terms of to align them, to have that alignment, okay, it can be a simple thing like getting a magnet, putting a magnet just beside the bar, but that will only be a temporary effect. Meaning once I remove the magnet, most likely the effects will be gone from the metal bar. So how do I imbue magnetism permanently to make sure the effect lasts longer onto the metal bar? There are a few methods that we look at. Okay, now the first method that we look at is what we call stroking. What you are doing here is the same as the previous example. I use a magnet bar, I bring it nearer. So what you're doing now is you, instead of just leaving it there, what you're going to do is you're going to stroke the magnet. So for example, if I use a north pole, I'm just going to repeat this motion from front all the way to the end. Okay, so from the beginning of the bar to the end of the bar, I'm just going to let my north pole pass through it. I'm going to stroke it. I'm going to touch it. Okay, touch the metal bar with my magnet. I'm going to stroke the magnet. Okay, sorry. I'm going to stroke the metal bar using my magnet. What you're actually trying to do now is you are doing one simple thing. You are like training the domains to actually fall in or to actually align in a certain orientation. Okay, so the domain inside here, all the domains here, because of this north pole moving through, they will be aligned in a certain directions. Okay, and this is what you're trying to do. You're trying to align the domains such that every one of them is aligned. And remember the previous example, previous slide, when they're aligned, you will have your magnetism effect on the bar itself. Okay, what we call you gain is magnetism. So by stroking the north pole, okay, the north pole you stroke all the way in, okay, you will find that the first point of contact will eventually become a north pole, and the last point of contact will become a south pole. Okay, so if you stroke using a north pole, the first point of contact, the bar will become a magnet after maybe you stroke like 500 times, 400 times. Okay, you need to train it a few hundred strokes. It's not that one or two strokes, wow, the magnet is formed. No, it has to be done consistently. Okay, he has done repetitive 400, 500 strokes. The same thing, the stronger you stroke, the longer you stroke, the stronger is the magnetism. So after stroking, you'll find that the bar, okay, all the domains will be aligned in the same orientation. Okay, whereby this will be a north pole, this will be a south pole. Okay, that's what stroking is about. Okay, you actually use the magnet to stroke the iron bar to actually train the domain or to actually align the domain such that you have magnetism on it. Now, the keywords that we are looking out for stroking, the keywords that we are when we use for stroking, as a student you write out, you explain stroking, you have to make sure that the process of stroking a few hundred times, you have to explain to the marker that you are actually aligning the domains. So these are what we mean by the keywords that you have to use, okay, and to gain magnetism, okay. So these are the keywords that we are talking about when you're explaining stroking. Okay, there are other methods and there are other keywords that you have to take note of when you want to explain the method to the marker itself. Okay, and similarly, you have electrical method, okay, where we call a direct current. Okay, this is one of the common thing that you learn in your primary school or even your lower sec, whereby when you pass a current through, when you set up a current flowing through the wire, you have a few standard effect that we look at. For lower side, we look at one thing is electrical heating effect. When current passes through a wire, you have a heating effect. And when current passes through a wire, you have your magnetism effect and your chemical effect. And this magnetic effect is what we are using now. You'll find that when the current passes through, this is plus and minus. flow through in the wire, you'll find the current flow through in a certain orientation. Okay, it's flowing from behind to the front, or what you call the current is flowing downwards. Okay, flowing through the metal bar through what we call a solenoid. This coil is what we call a solenoid. Okay, a coil of wires. Okay, so when I flowing through, you will find that the direction, because I have a constant current flow. Okay, I have a constant current flow. Okay, you'll find that my domains inside the magnet bar, in the metal bar, will be aligned. Okay, same thing. This is the keyword. Okay, and what you're trying to do is you actually to align the domains. And because of that, same thing of alignment, after putting it inside, after putting the wire, the metal bar inside the solenoid, the wire, and the current flowing in a fixed direction, you'll find that the metal bar will actually now possess a magnetic effect. Okay. Now, this is how we look at the pole of the thing. This is what we call the Maxwell right hand grip rule. Okay, you grip the metal bar. Okay, you grip using your right hand. You have to use the right hand. Okay, you have to use the right hand. Okay, the finger will follow the current direction. So which means if your current is flowing downwards, okay, so let's say this is the metal bar. So the current is flowing, the solenoid is here. So you have to look at the circuit to see where the current is flowing. For this question here, you'll find that the current is flowing from the back to the front and downwards. So what happens is your fingertips will be your current. So you're going to curl it. Okay, so you curl it. Okay, and once you curl it, the thumb will represent the North Pole. Okay, so if you look at the orientation for the picture here, you wrap your fingers around the bar. Okay, you wrap it. Okay, you wrap it around. You'll find that your thumbs will point to the right side. Okay, to your right, and the right side will be a North Pole, and that's what we call your Maxwell right hand grip rule. Okay, this is what we call your Maxwell right hand grip rule. Okay, this is the idea of using your your thumb to find the North Pole, and you will know that which corner or which side of the metal bar will be your North Pole. Similarly, to demagnetize, okay, once you know how to make a magnet, you need to know how to demagnetize, or what you call remove the magnetism. And the keywords that we are using here, okay, is actually quite standard, okay. But here, I will offer you 3 ways to so-called demagnetize the magnet, to remove the magnetism. One is by hitting. Okay, when you heat up the metal bar, you'll find that the domains of the atoms will gain energy and they will vibrate vigorously. And because of that, okay, you will be able to misalign the magnetic domain. So this is what we mean by the keywords. Okay, you have your idea of demagnetizing is to actually to misalign the domain, causing the domain to point randomly. And when they point randomly, the magnetic effect will be cancelled out. And of course, to play safe, you have to make sure the magnet cool down in the east-west direction. So this is the second keyword that we are using. It has to be east-west, because if you leave it in a north-south direction, the Earth magnetic field will again imbue magnetism effect onto that rod. So you will still, if it's in the north-south direction, your metal bar will still be imbued with a north-south magnetic pole, which is, it could be weak, but the magnetism will still be there. The other method is hammering, which is literally hammer. I just hammer. So what you're trying to do is you're trying to hammer on hitting and hammering. You're trying to do one thing. You're trying to pass energy to the domains. And what it does, it causes the domains, okay, for both of them to vibrate vigorously and to actually lose its alignment. And so the keywords for both of them is the same. You have to do it in the east-west directions. Okay, this is what I mean by keywords. Okay, and the main task of you giving energy to the domains is actually to misalign the domains. So with demagnetizing, you have 3 methods. The first 2 are actually fairly simple. Okay, to actually misalign the domain, and it has to be east-west direction. And in fact, the third method is actually the same keywords, but just that the way we use is a bit different. We use the electric current now, and we use what we call the alternating current. Alternating current is whereby the current changes direction. It changes direction now. Okay, the previous one that I mentioned, okay, the previous one that I mentioned, to make a magnet, I use a direct current. This is what we call direct current, DC. Okay, whereby the current flow is a single direction. Okay, oh, sorry, this one is the wrong direction. This is this way. Okay, direct current means it's a single direction, whereby a single direction, okay, you have a constant flow, or what you call a constant direction, where I am able to make the magnet this way. So if for me to demagnetize the magnet, I need to reverse it. So I need to use a alternating current. I need the direction to change current every second. And because I keep changing direction, my domains will be aligning left, right, left, right, left, right. And what it does, it actually misalign the domains. Okay, it confuse the domain, and as a result, misalign the domain. And similarly, it usually in the east-west direction. East-west direction, because why? Because of the Earth magnetic field, north-south. If I remove the demagnetized magnet in the north-south direction, the Earth magnetic field north-south will actually imbue a weak magnetism onto the metal bar again. So my metal bar, when it draw up, we draw it in the east, north-south direction, my metal bar will still be a weak magnet. So I cannot destroy the magnetism completely. To do it, I need to withdraw in the east-west direction after misaligning all the domains. So this is what we mean by the keywords. Okay, it's relatively simple because it's all the same. It's just that the methodology is different. Okay, so this is where I end off. Okay, it's a simple thing whereby I talk about how to make a magnet. And after that, we talk about how to destroy a magnet. Okay, I give you 2 ways to do it. Okay, 3 ways to destroy it. Okay, both idea is the same. You need to take a look at the keywords. You need to take a look at the setting. Okay, to destroy and to make, they are quite fairly simple. Okay, just to take note, the rule of thumb is the keywords that you need to illustrate to the marker. Same thing, if you have any comments, okay, any questions, leave your questions or comments in the comment bar below. Okay, and remember to subscribe to my channel to get the latest update of the upcoming topics or explanation that will be given to you. Okay, if not, okay, thank you very much.